Hello students, welcome back to the channel. Why does hydrogen combine with one chlorine atom forming HCl, whereas oxygen combines with two hydrogen atoms forming a molecule of water? And why does copper shows a variable valency of 1 and 2? So today we will understand valency and variable valency in the easiest way possible. Now defining the term, what is valency? Valency is the combining capacity of an atom. If we take the example of HCl, water and ammonia. Okay, now here in all the three examples, if you see, we have got hydrogen atoms in each of these compounds. Now in the first case, one hydrogen atom is combining with one atom of chlorine. So the valency of chlorine with respect to the number of hydrogen atom here becomes 1, because one hydrogen atom is combining with chlorine. Now here valency of oxygen with respect to the number of hydrogen atoms, how many hydrogen atoms are combining? 2 hydrogen atom. So the valency of oxygen here becomes 2. And in the last case, the valency of nitrogen becomes 3, because the number of hydrogen atoms which are combining with nitrogen is 3. So simply speaking, it tells us how many atoms of hydrogen can combine with one atom of another element. And the definition which you can remember is, it is the number of hydrogen atoms which can combine with one atom of the element forming a compound. Now moving on to the next concept, that is positive and negative valency. Now we have already seen that metals, they always lose electrons, and because metals, they lose electrons, they form positively charged cations. We have the example of sodium. Sodium loses one electron and it forms positively charged cation. Next, non-metals, they always gain electrons. And because they gain electrons, they form negatively charged anions. So chlorine gains an electron to form negatively charged anion. So this is an important concept. Metals, they will always give, they are very generous, they always give, and non-metals, they always take, they keep on taking. So that is how the give and take relationship eventually helps in the compound formation. So here we are seeing that metals, they always give electrons, they form positively charged cations, and non-metals, they always gain electrons forming negatively charged anions. Okay, so these are the two examples which you need to remember for positive and negative valency. Now the second definition is, valency is also the number of electrons an atom can donate or accept so as to achieve stable electronic configuration of the nearest noble gas. So we saw the example of sodium. Sodium is donating, hence forming positively charged cation. Chlorine is accepting, and hence it is forming negatively charged anion. Okay, and depending upon the number of electrons which are donated or accepted corresponds to the valency. So here in both the cases, they are giving 1 and taking 1, so they will be called as monovalent. Okay, monovalent valency. In case of magnesium, because it will give 2, it will be showing divalent valency. And aluminium also gives 3 electron, hence it will be showing trivalent valency. Okay, so mono means 1, di means 2, and tri means 3. So this is the other definition which you can remember and is important. Now coming to the valency chart. Valency chart is very important, you have to learn, because if you don't learn the valency chart, then it becomes difficult to frame the chemical formula. So this definitely you have to learn. Potassium symbol is 1, valency is 1 plus. Here we are seeing all the monovalent valencies. Okay, monovalent. Sodium symbol Na, its valency is 1 plus. Hydrogen symbol S, its valency is 1 plus, and ammonium ion is NH4 and its valency is also 1 plus. Now an important question which comes for ammonium, it is the only positive radical, very important. What are radicals? Radicals are a group of atoms of elements that behave like a single unit. So which are the group of atoms over here? Nitrogen and hydrogen, that are behaving as a single unit and showing a valency of 1 plus. So very important. In your MCQs or in your one word answer, it may be asked, name the only positive radical. You will say it is ammonium ion. Next, coming to the divalent elements showing 2 valency. We have calcium, its valency is 2 plus. Magnesium, it is Mg, its valency is 2 plus. All divalent elements here we are writing. Zinc is again 2 plus. Barium is Ba, it shows a valency of 2 plus. Very, very important. Then nickel also, it is Ni, and here also valency is 2 plus. Now aluminium and chromium, they show a valency of 3. So they will be classified as trivalent. Okay, trivalent meaning showing 3 valency. So aluminium is Al and its valency will be 3 plus. Chromium is Cr and its valency will be 3 plus. Okay, next we will move to the negative valencies. Okay, here also monovalent valencies we are seeing negative. Chlorine, bromine, iodine, all 3 will be showing a valency of -1. Nitrate is 1 minus. Okay, nitrate, NO3, 1 minus. 8 means more number of oxygen atoms. Okay, hydroxide will be a radical having 1 minus as the valency. Bicarbonate, bisulfite, bisulfate, all will start with H. So bicarbonate is HCO3 having a valency of 1 minus. Bisulfite, ite is HSO3, 1 minus. Ite means less, 8 means more, and bisulfate will be HSO4 having a valency of 1 minus. So all the bis will be having hydrogen in its radical. Okay, then we have aluminate. Aluminate is AlO2 having a valency of 1 minus. Permanganate will be MnO4, 1 minus. Oxygen or oxide will be 2 minus. Sulfur, or we also call it as sulfide, IDE. Sulfide will be S2 minus. Sulfite, SO3, 2 minus. Sulfate, again more number of oxygen atoms, SO4, 2 minus. Carbonate is CO3, 2 minus, and dichromate will be Cr2O7 having a valency of 2 minus. So all these valencies and their symbols you need to learn. Next we have zincate. Zincate is ZnO2, 2 minus. Plumbite will be PbO2, O2, 2 minus, showing a valency of 2 minus. Phosphate is PO4, 3 minus. Okay, 8 more number of oxygen. And nitrogen, also called as nitride, IDE, nitride, it will be N3 minus. Okay, so the valency chart you need to memorize. Every day please go through it so that you become well versed with the symbols and their valencies. Next we have the concept of variable valency. Now variable valency is at times very confusing for many students because it shows 2 or 3 valencies of a single element. So some elements can show more than one valency, and that is what the variable valency is the concept all about. So it is the number of electrons lost or gained from the outer shell of an atom during a chemical reaction, and when there is variation in this loss or gain, it results in variable valency. So copper shows a variable valency of 1 and 2. It means the outermost shell loses 1 electron, and sometimes the second shell, from the second shell also the electron jump outwards, from the inner shell also the electron jump outwards, which results in valency 2. Silver also shows variable valency of 1 and 2. Mercury also shows a variable valency of 1 and 2. Now here the Latin names are important. Silver is argentum, mercury is hydrargyrum. Then only you can write the symbols correctly. And all the first three elements are showing a variable valency of 1 and 2. Iron shows a variable valency of 2 and 3. Then tin shows a variable valency. Tin is tannous. It shows a variable valency of 2 and 4. Lead is plumbum. It shows a variable valency of 2 and 4. Gold is what? Aurum. Aurum shows a variable valency of 1 and 3. And lastly, manganese shows a variable valency of 2 and 4. So all these variable valencies you need to memorize in order to write the chemical formulas. Now the last thing which we are going to see is the example of copper. We know that the Latin name of copper is cuprum. Now there are two methods of naming the compounds. The old nomenclature or the old system of naming was that when a copper is showing a variable valency of 1 and 2, the lower valency will get the suffix OUS. So the name becomes OUS, that is cuprous, and with the higher valency the suffix becomes Icse, cupric, and the lower valency the suffix becomes OUS. So this you need to remember. And the new nomenclature or the IUPAC nomenclature is that we simply write the Roman letters. Copper 1 is Roman number 1 and copper 2 is Roman number 2. So that is how we name the compounds when we are dealing with variable valency. So if you have understood and followed, please do like and share. And if you have any queries, please put a comment in the comment section and we'll see you in the next video. Thank you, students.